you'll learn what a stemplot is, how to create stemplots from raw data, and how to interpret stemplots that were created by others. By the way, stemplots are also known as stem and leaf plots. First, let's talk about what a stemplot is. A stemplot is used to display quantitative data, generally from small data sets, say 50 or fewer observations. This stemplot shows IQ scores for 30 students. The entries on the left are called stems, and the entries on the right are called leaves. Each leaf represents a single value from the dataset. In this example, our dataset consists of 30 IQ scores, so the stemplot has 30 leaves. The IQ score represented by an individual leaf is equal to the value of the stem plus the value of the leaf. In this stemplot, the stem represents tens and the leaves represent ones. Sometimes, but not always, a stemplot will include a key to help readers interpret values correctly. Here, the key tells us that a stem of 11 and a leaf of 7 represent an IQ score of 110 plus 7, or 117. From this key, you can figure out that the stems represent tens and the leaves represent ones. In practice, stems and leaves are usually not labeled explicitly, so the final stemplot might look like this. And often, stemplots do not include a key, so a really bare-bones stemplot could even look like this. Even without a key, you should be able to figure out the value of each leaf. For example, consider the leaf shown in red. This leaf is associated with a stem of 10. A stem of 10 represents 10 tens, or 100. So this red leaf represents an IQ score of 100 plus 9, or 109. Now, let's work through an example to show how to create a stemplot from raw data. For data, we're going to use the body temperature of 16 hospital patients. Creating a stemplot from these body temperatures is a 3-step process. Step 1. Define stems and leaves. Here it makes sense to use the whole number portion of the temperature for the stem and the decimal portion for the leaves, which will appear to the right of the vertical line. And to help readers interpret our stemplot correctly, we will add a key. We'll position each observation one by one on the leaf portion of the plot. It is good practice to position each observation in numerical order on each row. So we will start with the lowest temperature and work our way up. The lowest temperature is 97.8, which we add to the bottom of the row of the stemplot, as so. You see how this works. A stem of 97 and a leaf of 8 represents a temperature of 97.8. The next highest temperature is 98.2, which we add to the next row. Here, a stem of 98 plus a leaf of 2 represents a temperature of 98.2. We continue in this way, adding leaves to the stemplot until all the temperatures are accounted for. 98.6, 98.9, 99.1, 99.3, 99.6, 100.5, 101.1, 101.2, 101.7, 101.8, 102.3, 102.5, 102.7, and finally 104.1. Notice that each observation in the list of temperatures appears as a leaf in the stemplot. Let's talk about how to interpret patterns of data represented by a stemplot. Stemplots display quantitative data, and from previous lessons, we know that quantitative displays can be interpreted in terms of 4 factors: spread, centrality, shape, and unusual features. Based on these factors, how would we interpret the data set represented by this stemplot? In terms of spread, we would say that the temperatures range from 97.8 to 104.1. In terms of centrality, the distribution is centered between 100.5 and 101.1. In terms of shape, the distribution is sort of bimodal, with one peak at the 98 and 99 stems, and the other peak at the 101 and 102 stems. And finally, in terms of unusual features, there are no outliers, but there is a gap at the 103 stem. Let's review. A stemplot is used to display quantitative data, generally from small data sets, say 50 or fewer observations. In a stemplot, entries to the left of the vertical line are called stems, and entries to the right are called leaves. The value of individual observations is equal to the value of the stem plus the value of the leaf. For example, the leaf shown in red has a stem equal to 10, which stands for 10 tens or 100. It has a leaf equal to 5, so it is equal to 100 plus 5 or 105. And finally, some stemplots include a key to help the user interpret the display correctly.